Hey, welcome to my talk, Improve Your Developer Experiences with Spring Boot Dev Services. I'm Moritz Halbritter from the Spring Boot team. I'm an engineer in the Spring Boot team and worked on the 3.1 release on the Docker Compose stuff and test containers feature I'm going to show you now. You should already know the required disclaimer slide. I'm going to leave it a bit so you can read it carefully. Okay. Let's talk about what's the problem. Why did I do this talk? So imagine you found some awesome open source project and you want to contribute to, and in the README there's this. So for getting started on developing, what you need on your local machine is a PostgreSQL server in 15.1 running on that port, and then Kafka and a Redis and Elasticsearch and a Mongo database. And of course it's built in a microservice architecture. So this not only needs this stuff, but also other services, which it depends on, and all those services have other dependencies too. Would you contribute to that project? I guess not, because, I mean, setting all that stuff up on your local machine is really a pain. So what's creating the problem? And when you look at modern applications, usually they are using a lot of external dependencies. For example, in my showcase, there's an Elasticsearch for search capabilities, there is a Postgres for data storage, there's a Kafka for messaging, there's a Redis for caching, there's a Mongo database for document storage, and it communicates with other services, and all of those services have their own dependencies of each own. Yeah, that's essentially the problem. Modern applications have a lot of dependencies. I mean, Spring Boot did not reinvent all the stuff. We built on already existing solutions. So what are those solutions? You may know the first logo, which is Docker. Yeah, it revolutionized the software engineering world by just packaging the software in small containers, which you then can run without all the fuss. You do not need to install any libraries on your system, just Docker, and it pulls images and it runs them and everything's working. The thing in the middle here, the Kraken, this is the logo of Docker Compose. And Docker Compose is building on top of Docker, and what you can do is you can essentially orchestrate multiple Docker containers which then work together. For example, you have a backend tier, you have a frontend tier, and you can wire them together. And the other logo, which is test containers. Test containers is the idea that when you run integration tests, you need those dependencies too. So test containers make sure that those dependencies are there when you run them by using Docker. So it starts Docker in the background and connects everything up, has a nice API on top of it. They have test containers cloud, for example, if you do not want to run your Docker daemon on your local machine because it runs as root for whatever reasons. And you can then run in their cloud, for example. So those are the existing solutions. So what's new in Spring Boot 3.1? We added Docker Compose support, like you've seen in the keynote already. How's it working? So if you go to start.spring.io and you select your PostgreSQL driver and the Docker Compose support, what you essentially get is this dependency, which is the Docker Compose dependency, and it generates a Docker Compose file for you. And the content of this Docker Compose file depends on the dependencies you selected above. So if you select Postgres, you get a Postgres. If you select a MongoDB, you get a MongoDB. If you select Elasticsearch, you get an Elasticsearch, okay? And when you started stuff up, so you download the project, you run the main method, you do not do anything else, it starts up, it finds your Docker Compose file, it runs Docker Compose up for you. That means Docker Compose is then pulling all the images, it starts the services, and when it's ready, Spring Boot auto-configures itself to use the services running inside this Docker Compose. In my example, I'm always using the Postgres example. It wires up the data source, it connects against the Postgres system, and then it's work. If you stop this thingy, it will call Docker Compose stop for you, which stops the container but does not delete any state. So if you run Docker Compose down, it throws away the state, but if we're running Docker Compose stop by default, which just stops your containers, okay? That means you run the application, everything's working, you stop the application, the containers is gone, everything is cleaned up, great. Let's see this in action. It's a small animated GIF, which is like very small, I hope you can read it. What you essentially see is, it starts up the application, then you can see it's executing a SQL query here. This SQL query then initializes the Hikari data, connection pool, it returns the Postgres, and it stops. And behind the scenes, it starts Docker Compose, configures itself to use it, and then runs down. How does its stuff work behind the covers? Because this is your Docker Compose file, and what's in there is a Postgres database with some environment variables and a port. And somehow this stuff has to be translated in those well-known spring.datasource.url properties, or the username or the password. So what's happening here? If you look closely, you see that this port here is not the same port like here, because this is a Docker Compose feature which uses dynamic ports. It just finds a random open or available port on your machine and then remaps it. Every time you rerun this port is different, which makes it even more complicated. So what's putting those properties in place? And for that, we need to talk about the connection details abstraction. The connection details is an empty interface, and I'm going to steal the joke from Josh here. It has 3 orders, so we thought about that empty interface very hard. And the idea is that this interface it provides the details how to connect to a dependency, essentially, to connect to a remote service. And of course, you see the small arrow here. This is not the only interface. There are more interfaces in there. Okay, there is, for example, a Redis connection details, which knows how to provide details how to connect to a Redis. The JDBC thing we're going to talk in details. R2DBC if you're running reactive connections. The Rabbit connection for RabbitMQ and stuff like this. So every supported technology has their own interface, and those are those which are implemented right now. So let's talk about the JDBC connection details. If you think about the JDBC connection, all Spring Boot needs to know is the JDBC URL, the username, and the password. And all the other stuff, like the Hikari pool connection, how many connections in the pool or something like this, it's not really useful for Spring Boot itself. It only needs to really know about the JDBC URL, username, password. There are 2 methods more in there, but they have default implementations, so we do not need to think about them. And if you look at the Spring Boot core module, there is one implementation of this interface which is called properties JDBC connection details. And if you take a look at our auto configuration, so this is a screenshot of our auto configuration. It is annotated with conditional at missing bean, which means if there is none other JDBC connection detail in the bean context, then this thing takes its place. Okay, so there is always such a JDBC connection details bean. If there is none, Spring Boot creates this one, and what this does is it essentially reads your configuration file and bridges the spring.datasource.something properties to this new abstraction. So now we got the JDBC connection details, but something has to use it. This thing here is a screenshot from our Hikari data source auto configuration, which configures the connection pool, which powers the data source abstraction in Spring Boot essentially. And here, this JDBC connection details thingy is used. If you do not use Docker Compose or test containers, the actual runtime class of this JDBC connection details is the property thingy, but when you run test containers or Docker Compose, this is another instance, and I'm going to show that afterwards. And what we're going to do with the connection details is we pass it to create data source, and when we follow this, you see here it's using the data source builder, and here it reads the URL, the username, and the password. And that's how the magic behind the covers works, essentially. There is this bean, it's either get filled from the properties or from some other source, and then we pass it into the auto configuration, which then configures the connection pool, which then connects to the database, and everything starts working by magic. Okay, now that we know that there is a nice little abstraction behind the covers, let's talk about Docker Compose, because the Docker Compose thingy is built on top of that abstraction. And here you can see there is the connection details, and you got, for example, 2 implementations of it. The one is the MySQL JDBC Docker Compose connection details abstract proxy factory bean pattern. And the other thing is the Postgres JDBC Docker Compose connection details, because we really like long class names. Okay, and the Postgres JDBC connection Docker Compose connection details knows how to parse this Docker Compose configuration essentially. So what it's doing is, it gets activated when it finds something which uses the Postgres image, and then it reads the environment. It finds out how the database is named, how your username is named, and how the password is named, and then it essentially returns this on this get JDBC URL, get username, get password. Okay, this is how the Docker Compose side gets wired up into the auto configuration and then ends up bootstrapping the connections. I used all my UML presentation skills to create the sequence diagram for you. And what's happening when you start the main method of the application is Spring Boot starts up, and then it asks Docker Compose, hey, is there something running? And Docker Compose says, nope, it's not running, and it runs Docker Compose up for you. Docker Compose starts the containers, waits until all the services are ready, and then comes back and says, hey, Spring Boot, everything's ready. Spring Boot then asks Docker Compose, hey, what's running now? Docker Compose, in my example here, is running a Redis and a PostgreSQL. And what the Docker Compose module of Spring Boot is doing now is creating connection details for the Postgres, and it's creating connection details for the Redis. And those connection details are then used in the data source auto configuration and in the Redis connector auto configuration. And that means the Hikari data pool connects to the Postgres, the Redis connector connects to the Redis thingy, which are both running in Docker Compose. And then the startup is completed, your business logic starts to run, the data source are bootstrapped, everything is working, you can talk to Redis and you can talk to Postgres. And if you shut down the application context, it's calling Docker Compose stop, Docker Compose stops the container via Docker, and the main method exits and the JVM exits. That's essentially what's happening behind the scenes when you do this stuff. Let's see it in action. When you run it, it essentially starts Docker Compose up for you, inspects all the services, connecting, and here you can see, I hope you can see it because it's unfortunately very small. Here is JDBC connection details class, so I put a little bit of code in there which prints out what the actual class of the JDBC connection details really is. And it is indeed the Postgres JDBC Docker Compose connection details, with the URL pointing to your Docker Compose. It's read the database here, it read the username and the secret from the Docker environment and puts it all in. The auto configuration uses it. You can use here the select one from SQL, and it returns the result and the application is done. That's essentially the magic which is powering this new feature. So now you're asking, why are you telling me details of implementations inside Spring Boot? What are you going to do with this knowledge? So the first thing, what you can now do is you can implement your own JDBC connection details bean for whatever reason. For example, say you're running in a cloud environment and you know that every application of yours has an associated database. What you can now do is you can create your own configuration which finds out, is it running in this cloud right now? Then automatically finds the database. It just sets, it creates a bean of JDBC connection details, and this stuff is used in the auto configuration. Everything starts working by magic. You just deploy it to your own cloud with a little bit of your own code, it starts working. Some small how-tos, how to use custom images. For example, when you're not using the official images, but you're creating your own images because you want some security hardening or whatever, you can do that too. Just use in the image tag your own image and then put a label on it, which is called org.springframework.boot.service connection. And there you put in the original image name, Postgres or Redis, and then Spring Boot treats it like the official image. The only thing you need to keep in mind is you do not fiddle around with those environment variables, because we use them to find out how the database is called, how the username is called, how the secret is, how the password is set. So if you use other variables, it starts failing. How to ignore services. For example, you have two Postgreses and one is the master and one is the replication. And you want to ignore one of those because by default it binds against all the services which it can find. just put the ignore label on it and Spring Boot will leave it alone. It will still run Docker Compose up and Docker Compose stop for you, but it will not bind against the thingy, so it will not create any configurations for that. How to share services. For example, you want to share a database, which is not recommended, or you want to use a Kafka, which is shared between two applications. It's possible too. The first application here is using the Docker Compose file. And here you set the Docker Compose lifecycle management to start only. That means it's running Docker Compose up, but it will not run Docker Compose stop for you. And on the second application, you point it to the compose file of the first application and also set start only. So if you run the second application first, it will see Docker Compose is not running yet and will start it. And if you run the application one, then it will see it's running already, it binds against it, and both are using the same database, and vice versa. If you run application one first, it starts the database up, and if you run the second, it will see, oh, it's running already, and it binds against it. The thing with the start only you need, because if you do not put start only in there and you stop one of those applications, it would stop the database, which is used by the other service too, and then stuff starts breaking. The only caveat of this pattern is that you need to stop the containers by hand. Okay, that's the only problem. Otherwise, it works perfectly fine. It works with Elasticsearch, Cassandra, Kafka. So I tested it with a Kafka consumer and a Kafka producer, and it's working fine. Okay, so that was the magic behind the Docker Compose thingy. And now we are going to talk about the test container support, which is new in Spring Boot 3.1. You can add the test containers dependency. And technically, this is not new, but we improved it in Spring Boot 3.1. If you select the test containers dependency, what you now get is a new dependency, which is called Spring Boot test containers. This is new. And here are the standard test containers dependencies, the JUnit integration, and the PostgreSQL driver, which is found out from this year, from the PostgreSQL dependency. If you use this before Spring Boot 3.1, your test looks like this. You have add test containers at the top of the class to mark it as a test containers test. You do your container field with add container, and then you normally do an add dynamic property source. And you need this dynamic property source to tell Spring Boot when this test is run that it needs to connect against the Postgres container JDBC URL, the username and the password. But with Spring Boot 3.1, you can just delete the dynamic property source. It's no longer necessary because Spring Boot now has learned how to find out that there is a test container and connects against it. The only thing you need to do is you slap add service connection on top of your container field. And this tells Spring Boot, hey Spring Boot, when you run this test, please configure yourself to use the test container there. And you do not need to fiddle around with properties and stuff like this. So this is just working. Behind the scenes, it's using connection details. So the same thing again, I'm running Gradle test, and there is a little bit of code in there which tells you which the JDBC connection details class is. And you've seen test containers starting the container. And here you can see the JDBC connection details class is now JDBC container connection details. Okay, this is the implementation which is powering the test container support behind the scenes. And here you can see the JDBC URL is pointing to the test container. You see it by the logger level off because that's the JDBC URL the container has created, and some username and some password. But besides that, it's using the same extraction like the Docker Compose thingy. Here, I used the Postgres container, the PostgreSQL container. But sometimes you need to use the generic container. For example, when you're using Redis, then it starts looking like this. The generic container, because there is no typed container for Redis, you use the generic container and give it the Redis image, and then you can specify the name of the container image as a parameter of the service connection. Technically, in this case, it's not necessary because the generic container instance is already there when the test is running, so Spring Boot just inspects it and finds out there is a Redis. But if you want to have more control over the container creation, you can also use a test configuration with a bean method. And in this case, you need to really annotate it for technical reasons because we can't really inspect the bean when it's in creation. For that, you need to essentially put in service connection name equals Redis. If you're using a custom image, for example, you can use the same trick. Your company Redis image in the generic container and the add service connection with add service connection with name equals Redis to point it to the official image, and stuff starts working. Same caveats with the Docker Compose, do not fiddle around with the environment variables. This feature is completely new, and this is what I have promised in the keynote. You can rip out Docker Compose and replace it with test containers. So why would you do this? I don't know, why would you do it? But we want to give you the choice, and you can do it if you want. If you want to use Docker Compose, totally fine, totally cool. We're going to support that, and it's working fine. If you want to use test containers for everything, totally cool too. The idea is, so technically, nothing is stopping you from using test containers in your production code, right? It's possible right now if you really want to do that. But we found a cool little way in Spring Boot 3.1 to make it even better. And the idea is use test containers for everything. You do not need Docker Compose anymore. If you use the Spring initializer, you will see that if you click on this test code down there, you see there is a test demo application. There is a main method inside the test source root. And I see your puzzled faces, and you're thinking, oh, what's this for black magic? Let's look at this test main method. So this is now the test demo application, which is living inside your test source folder. Okay, this is not main code. This is never deployed into your fat jars or your production container image. It's just your code. It's development code. And what it's doing is it's using Spring application.from, and then there's a fancy lambda which is pointing back to your real main method, which is living in the production code. And then there's a with method, which means take the configuration from the original main thingy, but then enhance it with itself, and then run it. Itself is a test configuration with one bean method in it. So that means when you run this application, it starts your application, it bootstraps the application context, and then it augments this context with this bean method, and this creates the PostgreSQL container and slaps add service connection on it. And what happens now is that when you run this main method, there is a PostgreSQL container with add service connection on it. It creates the JDBC connection details pointing to this container. It starts this container, and stuff starts working, and when you stop the application, this container is stopped. If you can run the test main methods either from the IDE by clicking on the small play icon, or with Gradle by Gradle U boot test run. It's a new goal, new task. And with Maven, it's Maven U Spring Boot test run goal. And this starts the test main method. You can see it in action here. Gradle W boot test run, and it starts up. And here you can already see the test containers, which is starting the test container thingy. And here you can see the JDBC connection details class is JDBC container connection details. It's the same class like in your tests. But now you can run it from the command line. And this essentially replaces Docker Compose, because now you don't need Docker Compose. The only thing you need to remember is to start a test main method, and everything starts working. You can throw away the Docker Compose file if you want. So why are there now two main methods? Why could we just not use the other one and maybe activate a test profile or something like this? The idea is the test containers dependency is scoped in the test compile scope. Okay, it's in Gradle it's test compile, and it's Maven it's test. The idea is we do not want to risk that the test container dependency ends up in your fat jar, which you then deploy to production, and which starts then talking to Docker, which would be not so cool. The test main method is the perfect place to put that stuff, because the test main method is already in the test compile scope. It can use all the dependencies you have in your test compile scope, so why not put it there? And we do not risk it that it ends up in the jar. And the idea is your main code is your production code, your test code is test code or your development code. That's the idea behind those two main methods. There's one thing, you can share container declarations now that you use the same container for tests and the same container for the test main method. And what you do is, you take the container declaration from your test and from your main method, from your test main method, and you put them all into an interface. And then you can import this interface in two places, mainly in test and in your test main method. And then you do not have to duplicate all the configuration for the container, just put it in one place and import it from this place. It works like this. This is the interface. You put in the container thingy and the service connection and the Postgres, and then on your test demo application, you use @import test containers and point it to this interface. And on a test, you essentially say, use this test container from the interface, and now they start using the same code. So you do not need to duplicate the code. Okay? That's the idea. It's a cute little trick. One problem with test containers is that test containers are designed for integration tests. And it's a feature for integration tests that they do not store their state. If you stop those containers, they throw away their state, okay? That means if you start your Postgres database and you're typing in like 4 hours of data, and then you're stopping this container, your data is gone. There are two tricks to avoid this. One is to use the dev tools in the test implementation scope, and then you can use the @restart scope method, @restart scope annotation on the bean method. And what this does is, when DevTools restarts your application, it normally recreates all beans. But beans which are annotated with @restart scope are not created. They are just left in place. They are not being closed and started again, which means this test container survives restarts. Okay, so it stores the state. If you stop the application, the state is gone. But while developing, you can slap @restart scope on it, and it even makes the restart faster because it do not need to wait for Postgres to come back up. The other thing, if you do not want to use the DevTools, you can use an experimental test containers feature. So this is really experimental. It's so experimental that you need to opt in by setting a property in your system. So if your stuff is starting to burn, it's not my fault. You have been warned. But what you can do is just call with reuse true, and then you can see that when you start this application, it finds out there is already a container with the same configuration, and it just reuses this container. This container is not stopped anymore because Spring Boot now knows that this is a reusable container. It will not close on it, so it will not shut it down, and it just leaves it running. And when you restart your application, it finds out, oh, there is already a container. I'm just going to use this. And this is much, much faster than starting a database. So you can see here, it starts in like 280 milliseconds, which is normally this starts in like 5 seconds when you need to create a Postgres container from scratch and wait until all the health checks are done. And this is much, much faster. And the benefit is it does not lose your data. Okay, your data is still there. Until you stop the container manually by Docker stop something, then your data is gone. You can see this in action here, the reusable test containers feature. And my laptop didn't start to burn, so I think it's fine. And here you can see it's really fast. It's reusing existing container, and it started in like 211 milliseconds. Okay, so it's just reusing the already running container. Okay, to summarize, you now learned a lot about the internals of Spring Boot. With the new Docker Compose support, you can essentially take a Docker Compose file, put it in your project, Spring Boot automatically finds it, it runs Docker Compose up for you, it configures itself to use the services, and it runs Docker Compose stop when you stop the application, which is quite nice developer experience, I think. You do not need to fiddle around with application properties or stuff like this, so no more application.properties fiddling, finding out, Googling JDBC, Postgres URLs and stuff like this, because Spring Boot just knows it, and it works. You can use the Docker Compose thing by default for application development and not for tests, but if you really want to use it for tests, you can just set a property that it runs in tests too, and you can run your tests against this Docker Compose thing. The test container support was already there. It's now have been improved with Edge Service Connection, which is quite nice because no more fiddling around with properties and stuff like this. Test containers are great for integration tests, and if you want, you can use them to provide the database or the other dependencies you need when developing this application. It's a cool alternative to Docker Compose if you want it, but you don't need to. You can just use it for integration tests, and it's fine. And with that, you got a great clone and run experience. Yeah, you can clone the repository, and you can just run the main or the test main method, and everything starts working by magic, like you've expected from Spring Boot. It just works out of the box. You clone it, you do not need to have to fiddle around with all readmes and 500 steps and stuff like this. It just starts working if there is a Docker Compose file and the test with test containers. And this is great because now you can spend your time in more important places than fiddling around with properties and reading readmes, and then this stuff does not work on the laptop from some colleague and stuff like this. Start the main method and it works. And with that, I'm at the end of my talk. There's more reading. If you want to read more about that, we have a 3-part blog post. The first about the connection details abstraction, the second about the Docker Compose support, and the third about the improved test container support in Spring Boot 3.1. You all got your photos? You just check the Spring blog. If you want to stay connected, then please let's continue the conversation. Scan this QR code or visit this great website I built with my awesome CSS skills. There are all the links to my Twitter, no, it's not called Twitter anymore, it's called X now. So the links to my X, the links to my Mastodon, LinkedIn, email address, it's all on there if you want to connect with me. I should remind you, please take the survey, because feedback is always important. And with that, I'm on the end. Thank you very much, and I'm open for questions. Yep. I think you need to go over there.
Hi.
Hi.
Are the Docker Compose and test container approaches to development suitable for monorepos?
Yep.
Thank you.
Yeah, they are suitable for monorepos. Just use all your dependencies you have in there, like the Postgres database, the Kafka, put it all in your Docker Compose thingy and run it. You can also, if you have a lot of dependencies which share stuff, you can put the Docker Compose file in the root of your repo and then reference it from all the services, and it should start working. Does this answer your question, or?
Yes, and how about for test containers?
The test container thingy, if you use this interface trick, which I've shown you, and you put it in a separate jar and then use this jar in all your services, it should work too. I've not tested it, but it should be.
Thank you.
You're welcome.
Hi.
Hi.
Is there any plan for supporting Podman and Kubernetes?
Yeah, thanks for the Podman question. So I'm using a Fedora as my working driver, and it got Podman, and this stuff works with Podman. Kubernetes support is not in there yet, and we do not have current plans to support it right now. It's suited for your local machine, but if you got like a good idea how to make it suitable for Kubernetes, just open an issue on our tracker, and then we are going to take a look at it. Yeah.
So can't these test containers be used for starting up other microservices that may be in the ecosystem?
Yep, could Cool question.
And how would I do that? How would you do that?
You can use the generic container to run any Docker image, which works, but you can also use test containers to build a container from a given Docker file and then run it. And then you can use it. But so Spring Boot starts the containers up, but it has nothing in there which understands your application and then auto-configures. But you can hook into the system which provides all this auto-configuration stuff and write your own integration. For example, to configure a REST client builder or something like this to connect against the other services.
So I thought the dependencies are what decides which what will go in the Docker Compose. So doesn't Spring Boot use the dependencies to decide how to build the Docker Compose files, or does that have to be supplied by me as a developer?
So the Docker Compose file, you are providing. You are providing the Docker Compose file.
But I didn't do that for Postgres, right?
Yeah, because for Postgres, it's a common component and we can generate it for you. But if you want to put your own system in there, put it in there and it will be started in the Docker Compose up and Docker Compose stop lifecycle.
So it looks and sees if the Docker Compose files and it leaves them alone, or it uses them, otherwise it will generate its own. So if it's a combination of both, a little Postgres, a little of my own, it can do both.
If you put a Postgres and your own service in the Docker Compose thingy, it will run Docker Compose up, which starts both containers, and then Spring Boot inspects both containers, and it will find out that it only can use the Postgres one, and it will leave your other thingy alone. There are no error messages, it just will configure up against the Postgres.
Thanks.
Thank you. Oh.
Question, how would you approach starting Redis cluster in a container? Yeah, if I want have several nodes.
Are we talking Docker Compose or test containers?
Test containers. Test
you
containers
have
and clusters.
I think you have to talk about that with a test containers expert. I've not used Docker Redis cluster in test containers, but for Docker Compose there are ready-made blueprints which are already configuring that stuff.
Okay, thanks.
Hi.
Oh, sorry. You're next.
All right. I saw in all your examples you used the annotation containers basically to start, stop, to use the test containers lifecycle.
Yeah.
If I start manually the test containers, so would it be still beneficial to use those new features? How can I hook up those new features from Spring Boot?
So this add service connection does not start or stop your container when running in a test containers test. This is test containers territory, and we do not touch that stuff. So if you run it yourself, for example, if you call run and stop, and you put add service connection on it, everything is working, and it uses the running container essentially. Does this answer your question?
Yeah, but if I do this inside my integration test, so like in that static method to start the whole kind of test suite. So from my understanding, so I'm not sure, maybe I just don't understand fully how you do this on the background, but if based on what I saw, so you would need to figure out what containers are running. So is it what would happen after that test suite is kind of set up?
So we do not find out which containers are running. We find out which containers you have annotated with add service connection. And now we know that you've annotated your Postgres container, and we do not care how this stuff is started. We just know there is one, and we are going to bind against.
Okay, got it. Thank you.
Thank you.
So I imagine you can probably do this with generic containers, but I'm just curious if there's any plans to add support for something like local stack to add like AWS, like mock AWS resources or anything like that. So
we have not thought about adding local stack support, but if that's a use case you have, please open an issue and then we can talk about it.
Sweet, thanks.
Thank you. Cool, that's it. I hope I have you not steamrolled with all the information, and have fun in Spring 1. If you bump into me on the hallway, just talk me up. Thank you.